Susie, can you please do all of number 27?
Mr. Pell, I shall write it on the whiteboard to the left of the learning room.
Can you explain to your classmates how to factor 4x2 plus 14x plus 10?
Yes, Mr. Pell, I would be exhilarated to be able to share my knowledge with the class.
Thank you, Susie.
I shall start to do the problem now. So you start off with seeing if you can multiply two numbers that go to 10 but have them still add to 14. So you aren't able to. In this case, you have to multiply 4 and 10 together. Finding two numbers that multiply to 40 but add to 14. They are 10 and 4. Now the problem is 2x plus 5, 2x plus 2, that is the final answer. Thank you. Thank you very much. I know you enjoy my company.
Susie, did you forget something?
No, Mr. Pell, I have done everything right.
No, Susie.
Yes, Mr. Pell.
Susie, look at the original problem.
I'm looking.
Susie, what do 4, 14, and 10 have in common?
They're all numbers.
Yes. Is there a greatest common factor?
Oh, they share a factor of 3.
No, Susie. Try again. This time think smaller.
Fine, 1.
No, the number is between 1 and 3.
2.5.
No.
What is it?
Why don't you call a friend to help you out in this difficult situation of factoring?
Fine.
Yes, honey?
Mr. Pell told me to call a friend.
I'm your mother, not a friend. But proceed.
What do 4, 14, and 10 have in common?
They are all math terms, sweetie.
Yeah, I got that. But factoring-wise, Mr. Pell, my mother doesn't know. May you please enlighten me?
Okay, you have been through enough trouble. The greatest common factor is 2.
Oh, why did I not think of that? My brain is not here right now.
Would you please stop saying that already? Try the problem again, but this time with the greatest common factor.
Okay, so you take 2 out of the equation, and now you have 2x2 plus 7x.
Very good, Susie. Now Susie, DOTS.
Oh my god, I love that candy, you must give it to me now.
No, Susie, dots as in difference of 2 squares, not the food.
I wanted food. Oh well, teach me how to factor.
Very well then, so dots. Susie, write this on the board, x4-16x2 plus 18.
Okay, Mr. Pell.
Factor it.
Here is what I got. x2 29x2 plus 2.
Is that all, Susie?
Yes.
Are you sure?
I already said yes.
Dots means difference of 2 squares. Can you identify 2 squares in this equation?
Try.
Very good, Susie. Now that you have identified the perfect squares, can you finish the factoring?
I understand it now. You have to the x2 2x.
My George. I think she's got it. Thank you, Susie. I have put you through enough trouble today. You may now take a seat. Okay, children. Now I will teach you about factoring quadratic trinomials. Here is an example. 6x2-25x plus 24. Does anyone know how to start?
We could find a GCF.
Yes, always try to identify a GCF first, but in this equation, there happens to not be a GCF. So what you want to do for this equation is split 25x into 2 parts. So for this problem, we want to split 25x into minus 16x and minus 9x. Can anyone tell me why you would do this?
To make factoring easier.
Correctamundo. So when you make it into a 4-term equation. So after that step you want to take out any GCFs you have now.
To make factoring easier.
That was when we had started out. That was a great question. Since you have expanded the equation, you now have some GCFs in this factorial equation. So the equation so far is 6x2-16x9x plus 24. When you take out the GCFs you get the equation 2, 3x8, minus 3, 3x8. In the first half of the equation, you had a GCF of 2, leaving you with 2, 3x8. And in the second part of this equation you had a GCF of minus 3 leaving you with minus 3, 3x8. You now combine your GCFs into one equation with parentheses, and leaving you 3x8 as one whole. Does anyone know what the equation would look like now?
It be 2x minus 3, 3x minus 3, 3x minus 8.
That is correct. Now that everyone understands, we shall move on to the next topic. We get to learn different techniques of grouping. Okay children, now we start grouping techniques. Our first problem is 3x2 plus 6x3 plus 2 plus 4x. Would anyone like to try?
I would.
Thank you Laura.
Would it be 3x2 plus 6x3, 2 plus 4x?
Not quite. There is a GCF. Try again.
Would it become 3x2, 1 plus 2x, 2, 1 plus 2x?
Yes Laura. Excellent improvement. The GCF for 3x2 plus 6x3 is 2x2. And the GCF of 2 plus 4x is 2. Please take note of that. Now, here's a harder problem. Be ready. We are using a different technique. So students, be ready. So does anyone want to try the problem 4y2-6x3y plus 8z?
Yeah, so you do 4y2, 6x, minus 3y plus 8z, then you would get the answer of 4y2, 9, 6x plus 8z, minus 3y.
Correct. Now you have learned all of these different things today. I hope you will one day go and use them in the real world. Goodbye, and thank you for attending Mr. Paulard's math class.